Okay, so since we already know how to write the confidence interval, when we say confidence interval, it's help us to determine how confident we are, okay, if the interval estimate is it's having a true population. Okay, let's proceed now to our discussion on sample size determination. So how do we determine a sample size? First, it is very important that you select a sample of appropriate size from the populations, since all statistical inference are based on the sample. Number 2, factors considered: desired level of confidence. When we say desired level of confidence, usually we use 0.05 level. Variability of the population being studied, and then specified margin of error. Okay, so we need to consider the two. But take note, too small a sample size might lead you to unreliable conclusion. Too big of sample size might exhaust you the resources. So to determine the sample size, okay, so the formula will be N is equal to Z alpha over 2 multiplied by the populations, multiplied by the standard deviation of the population, or the sigma, divided by E, which is the margin of error, raised to 2. Okay, sample size determination, N is equal to Z alpha over 2 multiplied by the sigma, or the standard deviation of the population, divided by the margin of error raised to 2. Why do we need to determine the sample? Okay, we need to determine the sample so that we know what will be the specific sample of the population. Because if it is too small, it can be unreliable. If it is too large, you can be exhausted to your resources. Okay, it's kind of exhausting if it's too large. So that's why we need to determine the sample size. Okay, let's start with example number 1. How large a sample should you take to be a 95% confident that the estimate of the true mean number of hours of sleep among adults will differ by no more than 0.30? A previous study showed a sample standard deviation is 1.95. Okay, so how do we answer this one? Okay, so N is equal to Z alpha over 2 multiplied by the standard deviation over E raised to 2. So since the standard deviation, okay, is the same as the sample standard deviation in this particular, so N will be, what is your Z alpha over 2? The given is 95% confidence. So first, identify your alpha. So that will be 1 minus 0.95. So your alpha will be 1 minus 0.95. That will be 0.05. So your Z alpha over 2 multiplied by the standard deviation over E raised to 2. So Z 0.05 divided by 2, that will be same as Z 0.05 divided by 2, 0.025. C 0.025 in the table, 0.0, that will be 1.96. So 1.96 multiplied by the standard dev, which is 1.95 over 0.30 raised to 2. Okay. So that will be 62.31 round up. So that will be 63. Okay. In getting the sample size, it should be round up. Okay. In getting the sample size, it should be round up. Okay. Next example, number 2. A scientist wishes to estimate the average depth of a river. He wants a 99% confident that the estimate accurate within is 2 feet. So the estimate accurate is within 2 feet. So that's the margin of error. From a previous study, the standard deviation. So the standard deviation is 4.33 feet. How big should his sample be? So n is equal to z alpha over 2 multiplied by standard deviation over the margin of error raised to 2. So what is the z alpha of 99%? So z alpha over 2, so 99%. So 1 minus 0.99. So 1 minus 0.99, that will be 0.01. Okay? So 0.01 divided by 2, that will be 0.005. So using the table, 0.005, that will be 2.575. Okay? So you do have n is equal to 2.575 multiplied by 4.33 over 2 raised to 2. So therefore, your answer is 31.2, round up. So that will be 32. So round up. Okay, that's it.